Hello everyone, this is a simple tutorial for continuous text-to-speech with the continuous speech analysis and synthesis system submitted for Show and Tell Interspeech 2020. Here we demonstrate our continuous vocoder in the text-to-speech. So our vocoder have three continuous parameters: fundamental frequency, maximum voiced frequency, and mild generalized pastoral. So in that figure, you can see how these parameters are extracted by the continuous vocoder from the database and then feed it to the neural network in order to get the high quality parameters. And after that, based on the input text, then that system can use the trained model, and then the synthesis speech can we get it at the end. Basically, the neural network, we have a feed-forward neural network and also recurrent neural network. Recurrent neural network, we have three important topologies: LSTM, PLSTM, and GRU. So how to run that model? Basically, we only need to run that shell file. So that file have 6 stages. So for example, the first step, it's checking the continuous vocoder requirements in the user system. And the second stage, it's setting up all the directories and downloaded the data. So here you can see how the directory structure that automatically created. The third step, it's preparing the configuration files for the acoustic model and also for duration model. The training duration model in the fourth step, and also the training acoustic vocoding model in the fifth step. The last step, it's synthesis speech. So I will show you now how can we run that model, but I will just type that file in my Ubuntu. So for example, now I will write that shell file, and I can press 1 enter. So as I can see here, the step 1 is checking for the missing package, and if everything is fine, then I will get a message like check done, which means that every libraries have installed successfully in my system. Otherwise, if one of these libraries not installed, then a message can appear to the user and request to install that missing library. The second step, it's downloading the data. Here I used the female speaker, which have more than 1,000 waveforms. The third step, it's preparing the configuration files for the acoustic and also for the durations. And in the fourth step, the training can start it for the duration and also for the acoustic model. So in the beginning, I will just show you what type of my neural network. So as you can see here, it's the feed-forward with the 6 tangent unit. And the size of the hidden layers, it's 1024. The acoustic parameter used in that model, it's the MGC, MVF, and also fundamental frequency. So based on these, the model can be started, and at the beginning, it will create or generate all the labels for all the data I have. So for example, I have like 1,132 waveforms, then it will generate 1,132 label file based on the state align. So for example, if I go down, and you can see how these files can generate it, and towards to the training model. So for example, in a second, you will see how the trained model can be built, and then the iterations can be started. So here we are. As you can see, this is the training DDN and the building that model, and then the epoch is started with the validation error and the training error. So for example, the default number for the iteration here, 25, but the user can change it based on their requirements. So on the time, so for example, from started at the end, that model can have like from 10 to 13 minutes to finish. I used the GPU here, and I think everything will be fine. So I will not wait until the finishing. So I will switch back to the test part in order to show you how we can test it. So again, simply, we only need to test that demo with that show file. So that if we need to run that show file, just need to type it and press enter, then they create the text directory in that path and then ask the user to enter their sentence, and the speech synthesis can be generated by continuous vocoder. So I will return back to the demo, and I will imagine that trained model have finished successfully in that model. So as I said, the default sentence was hello AI world, but the user can enter any sentence that they want. So for example, in my case, I will write typhoid. Did I tell you? So this is my sentence, and when I press enter, then it will create the lab files, and it will use the trained model, and at the end it will get like the synthesis file. So here we are. Is now construction has started.
Typhoid, did I tell you?
So yes, this is the last steps, and I hope it helps you. So this is the installation package that the user should install in their system. And if you have any questions, concern, then you can post it here, or you can contact us in our laboratories. So again, thank you very much, and have a nice day.